How are we doing? Am I audible at the back? Audio good? All right, seeing some enthusiastic thumbs up, full of energy, amazing. Super excited to be here at PyCon Germany 2025 to tell you about how Narwhals is silently bringing together the data ecosystem. My name is Marco Gorelli. I work at Quansight Labs. I've come here all the way from Cardiff, Wales to tell you about this. And before we begin, I've got a little service announcement, public service announcement for anyone else who, like me, does not live in Germany. There's something about German culture you absolutely need to know about, and that is Pfand. So the idea is that in Germany, you can get money back by recycling. So when you buy a plastic bottle, it often includes a little deposit, and then when you give it back, that deposit, Pfand as they call it, they give it back to you. You can give a bottle back and get 8 cents back. Getting money back for recycling is good. Unexpectedly getting money back when you didn't know you'd paid a deposit in the first place is even better. And my impression is that this is very good at incentivizing reduce, recycle, and reuse. It's good to reuse things. Cool, we're about a minute in, given latecomers a chance to walk in, so let's get the presentation started. Here's how it's going to work. I'm going to start by showing you a before versus after comparison of life before versus after Narwhals. Once you're all hyped up about Narwhals, we'll talk about how to use it. Going to have a little Narwhals crash course. Going to talk about how to do things, lazy versus eager, everything you need to know about row ordering, and then we'll dive deeper into further Narwhals concepts, because this is PyCon. We cannot just scratch the surface. So we're going to talk about perfect backwards compatibility policies, next steps, and what the Narwhals community is all about, and how you, yes, you and you, all of you, can get involved. And then maybe, hypothetically, perhaps, there's a chance, there's a possibility that I might, if I'm feeling brave enough, do some live coding. Maybe, no guarantees, but you seem like a friendly audience, so maybe I'll feel hyped enough to do it. Finally, we've got an engaging Q&A/awkward silence. You can, if you'd like to contribute to the Q&A, you can submit your questions on Slido somewhere. If you'd like to contribute to the awkward silence, then if the person next to you gets their phone out and submits a question to Slido, you can slap it out of their hand. Let's talk about life before Narwhals. So here's a comparison of plotting Polar's data frames with Plotly in 2024 versus in 2025. So Plotly version 6 came out in 2025, and Plotly version 5 was in 2024. So for Pandas users, things stayed about the same. But for Polar's users, things got 3 times faster, 10 times faster, and similarly for PyArrow users. What changed? Well, the answer is Narwhals changed. Plotly version 6 started using Narwhals as a lightweight compatibility layer between data frame libraries. So you might not have installed Narwhals directly yourselves, but chances are there's at least one data tool you're using which uses Narwhals under the hood to give a seamless experience to different data frame libraries. So that's what I mean when I say that Narwhals is silently changing the data landscape. Narwhals is a tool for tool builders, and it provides you with a single, unified API to support multiple data frame libraries, like Pandas, Polars, DuckDB, and etc. It's used by several major libraries, like Altair, Bokeh, Marimo, Plotly, Shiny, Hierarchical Forecast, and more. And we really care about minimizing the impact on existing Pandas users. So Narwhals comes with 0 required dependencies, and we really care about the developer experience. So it also comes with some very strong, perfect backwards compatibility policies and is fully statically typed. I'll say more about these last 2 points later because they merit their own slide. But before that, we need to talk about why this makes such a difference. Because before, data tools would typically only support Pandas, which is great if you're a Pandas user. And there's nothing wrong with being a Pandas user, but the issue is when everyone is forced to squash whatever they're coming from and go into Pandas. It's, for some cases, it's fine, but it's a missed opportunity. Like, it forces lazy data frames to become eager. It forces GPU data frames to go to CPU. It forces everybody to have an extra heavy dependency of Pandas in all their environments. And often it also requires PyArrow, not a lightweight dependency. The Narwhals solution, on the other hand, is that users can bring their own data frame. So if a user brings Polars, Narwhals will use Polars. If the user brings QDF, Narwhals will use QDF. If the user brings PyArrow, Narwhals uses PyArrow, and so on, without any of these being required dependencies. Now, it is possible to do all of this manually if you like. Like, you could not use Narwhals and just have a bad time making all of these if-then statements and handle, in fact, even this isn't enough. You would need some extra indented if-then statements to handle pandas before version 2, and then polars before version 1, and depending on how far you want to take it, you're going to have a very bad time writing all of these if-then statements for all of the different libraries. So instead, we had a bad time for you doing this in Narwhals, and you can just use the single unified API, which you can access via narwhals.from-native. Now, I've made a big deal out of dependencies. Now, why do I think dependencies are to be avoided if you possibly can when you're making libraries? So I think most of us in Python, we've encountered some frustrating error like this at some point. We've tried to install library A, but library A depends on library B, and then library C also depends on library B, but in an incompatible way. And so we end up with a broken environment, and we're not really sure what's going on, and nobody can reproduce our errors, and we end up in what's informally known as dependency hell. Whew. It's bad. Furthermore, extra dependencies can make it harder to support new versions of Python. If you want to support the new fancy version of Python and one of your dependencies does not support it, then that's enough to block you from supporting the new version of Python with your library. So in Narwhals, from day one, we've been very strict about certain conditions. So 0 required dependencies, no ifs, no buts, no typing extensions, no nothing. Extremely lightweight. It's just pure Python files. There's no compiled code. It should be impossible to not be able to install Narwhals so long as you've got a functioning Python installation. We also really care about developer experience. So Narwhals is fully statically typed, meaning you can run your favorite type checker on it, be it MyPy, PyWrite, PyAfly, RedNot. I'm so a big fan of RedNot there in the front. Was it Luca? Probably Luca. Right. And not only does this give you more safety when you're developing, but also it means that when you're developing code in your editor can provide you with more helpful suggestions. Like writing code when your libraries are fully statically typed is a much better experience than working with untyped libraries. We also care so much about developer experience that we make some perfect backwards compatibility guarantees, but those merit their own slides, so more on those later. Now that we're all hyped up about Narwhals, feeling energetic, feeling pumped, let's go on a little Narwhals crash course and learn how to use it. So first of all, there are 3 steps to writing a data frame agnostic function using Narwhals. 3 steps, 1, 2, 3. So step 1 is you're going to write from native. So the user passes something into you, you don't know what it is, but you can call from native, and this will wrap it in something that Narwhals can work with. Step 2, you express your logic using the polars API. Anyone familiar with polars might recognize this as being a subset of the polars API, so we use expressions. Here, what we're expressing is that we want to keep rows where species is gen2 and the body mass in grams is less than some given number. And then finally, once we're done expressing our data frame logic using this single unified API, we return it to the user by calling .toNative. Now, as for the polars API, some people ask me, why don't we use pandas as the single unified API within Narwhals? And the answer, you can find it if you ask any polars fan, any ever, why they use polars, and that is that they came for the speed, but they stayed for the syntax. And just like polars and Dr. Dre, Narwhals agrees that it's very important for you to express yourself. Let's have a little demo. If we start with a pandas data frame and you pass it to your function, you get back a pandas data frame, and all the computation happened using pandas. If you pass in a polars data frame, you get back polars, and all the computation happened using polars. If you pass in a DuckDB PyRelation, you get back a DuckDB PyRelation, and all the computation happened using DuckDB. All of this happened without any of the other libraries being required dependencies. And you should be able to express any fundamental data frame operation you like. There's also string operations, which, just like in polars, you can access using the .str namespace. You can convert to upper or lowercase, check if strings contain things or end with things, or the first bit of a string, how long they are, replace, slice, split. It should all be there, but we're open to further feature requests if you want more. There's the datetime operations, like extracting components, converting time zones, converting strings to dates and dates to strings. And there's also different kinds of joins, like left, outer, inner, semi, anti. There's also join as of, very underappreciated join, in which you join based on closest matches rather than based on inequality conditions. Did I forget anything? Yeah, I might have forgotten the right join. We should probably add it at some point, but so far nobody has asked us for it, which kind of confirms my prior that right joins are useless. Now, I've made a big deal out of lazy execution, so let's learn what that means. So we can broadly categorize data frames in eager and lazy. So eager ones, for example, we have pandas data frame, we've got polars data frame, there's PyArrow table, QDF data frame, and on the lazy side, we have data frames which defer their execution until the user asks for the results to be materialized, such as polars lazy frame, DuckDB PyRelation, PySpark data frame, Dask. These all have different models and different representations and different properties and all, but the main difference that we're interested in Narwhals is row order. So in the eager case, we assume that the data behaves as if it's in memory, and so there exists a physical row order. So it's perfectly well defined to do a sum based on physical row order, but in the lazy case, we make no such assumption. No assumption about your data or your compute, and we treat row order as if it's undefined. Just like you can't ask what's the first element of a Python set, because row order is undefined, row order in lazy frames is undefined. If this feels a bit abstract, let's go through a little example. This is the most technical part of the talk, so don't worry, we'll get back to memes very soon if it feels a bit too technical. So let's look at the cumulative sum operation. So in the eager case, if you want to do a cumulative sum, so that is to say, you start by summing values progressively in a certain order, and you accumulate them as you find new values. So 1, 4, 2, 5, the cumulative sum is 1, 5, 7, 12. In the eager case, this is perfectly well defined, because we assume that there is some physical row order, so that's the order that we compute the cumulative sum in. But if you try to do this with a lazy frame, Narwhals will tell you that no, you can't do this, because row order is never assumed in the lazy case. So how do you do a cumulative sum with a Narwhals lazy frame? The answer is you need to explicitly say in which order to do it. Like in this case, we've got a column which orders the data frame, date, so we can tell Narwhals, do the cumulative sum over ordered by date, and then, like this, Narwhals is able to do it. So this is perfectly compatible with polars, but it is an extra restriction on polars. And I think that's okay. Like, this extra restriction enables freedom, because it enables you to write portable code, which then you can execute on DuckDB, Daft, Data Fusion, any SQL front end. And yeah, sometimes restrictions enable freedom. Now, in starting to develop Narwhals, that's exactly what we wanted to accomplish. Like, let people just write their code once, focus on the data frame logic, and then get on with their lives. But there is an unexpected feature we ended up encountering. So I'd now like to give a little demonstration of that completely unexpected feature. So here's a little notebook. So I'm starting by just doing some imports, and then defining a data frame agnostic function. As a reminder, data frame agnostic functions in Narwhals, 3 steps. So from native, Narwhals API to native. So the user passes something in, we call from native on that. We then express our logic using the Narwhals API. So we're just going to keep certain rows. We're going to make some rolling means of different window sizes. And then we're going to sort. This is perfectly compatible with the polars API. If you're used to polars, this should feel familiar. OK, so we can then verify. OK, if we pass a pandas data frame in, we get pandas out. If we pass a polars data frame in, we get polars out. If we pass a polars lazy frame in, we get polars lazy out. So we need to call collect to view the results. And if we pass a DuckDB relation in, we get a DuckDB relation out. Now, quick show of hands. Of the audience that's familiar with polars, how many people feel like they could accurately translate this to SQL? Is the mic working? Okay. So take a look at this. Because we get back a DuckDB relation, we can call SQL query on the result, assign that to a variable. I'm then going to import SQL pass to make it look pretty. SQL pass dot format, SQL reindent equals true. Let's print, and voila, we have translated our Polars code to SQL. Unexpected feature, but I'll take it. Whoops, let's go back to the presentation. Where's the presentation gone? Here it is. This is why we don't do live demos. This is definitely why we don't do live demos. Slideshow, this will do. Okay, where did we get to? Okay, might need to skip some parts. Okay, yeah, backwards compatibility. Motivation is that deprecation cycles introduce issues, but what we do in Narwhals is we've got a main namespace in which we might change things, but we've also got a stable namespace in which the guarantee we make is that code you've written today will keep on working 10 years from now and for the future of Narwhals. This concept is inspired by Rust editions, and it's a bit of effort, but it's allowed us to make deprecations which have had no effect on the millions of people using Altair, Plotly, Marimo, and all the other libraries using Narwhals. As for who's behind Narwhals, I started the project in February 2024. I was pleasantly surprised to see people starting using it a few months later. And the project is completely community-driven. There's no Narwhals company behind it. I'm very grateful to my employer for allowing me to spend some unfunded work hours on the project. The community has grown to over 100 unique contributors, and we have bi-weekly community calls and a Discord server, which all of you are welcome to join if you'd like to make the project better. What's next? We'd like to get to narwhals.stable.v2, support extra lazy data frames, and support expressions in more places, and Narwhalify more libraries. Now, in confusion, what have we talked about today? We've talked about how Narwhals is a tool for tool builders, and it's silently changing the data ecosystem. It's widely adopted by packages such as Altair, Plotly, Marimo, Bokeh, and many others. It allows you to write code which supports pandas, PyArrow, PySpark, DuckDB, and more, just through a single unified API, which allows you to write reusable functions. Because with Narwhals, you can write reusable functions, and it's very good to reuse things. Especially if you're in Germany and you want to get your fund. Thank you, everybody. Thank you. Thank you. Thank you.
You see, your energy is totally contagious. Where do you get this energy from? What did you eat or drink?
Is that a question somebody submitted?
My question.
Must have been the coffee. Okay. So somebody put something in it.
Wow, lucky you. When I was watching you, I was also like jumping. Wait, I rushed you a bit, sorry. Like, my math skills are, I don't know, on the floor. But we have more time for questions.
All right.
So the most popular... Sorry?
Let's see what they've got. Hit me. Let's go. How many can we get through?
Do you dare? How does Narwhals handle performance-critical operations across backends without introducing significant overhead or losing backend-specific optimizations?
That's a fantastic question. So Narwhals doesn't do any compute. It literally just translates between APIs. So the overhead is just from doing some extra is-instance checks and some if-then statements in Python. So the answer is that, like, it's just extremely lightweight. We don't do anything clever, and we just let the backends handle all optimizations and all compute. So that's why when Plotly started to use Narwhals, maybe you would have naively expected that for Polars and PyArrow things get faster, but for pandas things get a bit slower because of the extra overhead. But actually things got a bit faster even for pandas because we've been so careful about eliminating all overhead in pandas. And as it turned out, Plotly also had some historic bugs fixed when they started using Narwhals for free because they were using pandas indexing not quite in the way it was intended to be used.
When I was watching you, I was thinking, whatever you are selling, I'm gonna buy.
Right.
So someone actually made a comment in the same direction. Sounds great, where do I sign?
Yeah, well, it's a pity there's no company behind Narwhals, but you can pip install Narwhals and join the party.
Oh my God, there are so many questions.
Okay, yeah, quick.
Yep.
Let's go through.
Let's go. Can you compare Narwhals to Ibis?
Can I compare Narwhals to Ibis?
Ibis.
Okay, so give me a sec. So, in conclusion, questions, extra slides just in case. How does Narwhals differ from Ibis? So, all right. Ibis provides a Pythonic front end to SQL engines and polars. We are not in competition. In fact, somebody's opened a pull request to support Ibis within Narwhals, and my hope is that within a month or so we can ship it.
What happens under the hood? How do the transformations work? Is there an intermediate frame you use?
Sorry, could you repeat, please?
Sure. What happens under the hood? How do you do the transformations work?
Yeah, so there's 3 layers within Narwhals. So there's the native layer, so that's what the user passes in. There's then the compliant layer, so that's what we translate everything to. And then there's the Narwhals API, which is what Narwhals developers interact with. So yeah, we're mapping to our kind of intermediate representation and then dispatching and translating things.
Next. Why is Polar syntax better than Pandas syntax?
Because expressions are inherently lazy and they allow you to do more optimizations. I'm going to take the chance to plug a talk I gave at PyData Amsterdam last year called Understanding Polar's Expressions When You're Used to Pandas. Check it out. It's a good, fun one with lots of memes, which I'm sure will surprise absolutely no one.
Mm-hmm. So someone was taking note of a talk from yesterday about dataframe-agnostic and Pandera for polars. So the question was why they use polars instead of Narwhals. How much effort does it require to port it from?
Yeah, so I think at the end of that presentation, somebody asked why they didn't use Narwhals, and it was not me. Believe it or not, you know you've made it when your project gets mentioned in other people's questions. And I don't know how much effort it would be because unfortunately I wasn't able to attend the presentation because the room was too full. I think the reason why they only support polars is that they were only interested in using polars. That's how much of a shift there's been within the landscape. Like they only use polars, they don't even use pandas anymore at their company. So I guess they just had no motivation to keep the bridge with pandas and with other data frame libraries.
Is there PySpark support?
Yes.
That's it?
Easy question.
How small is Narwhal's subset of the Polars API?
It's small enough to be lightweight, but extensive enough to be useful. Right?
There will be people voting for you if you go for politics.
All right, so my first policy is going to be to ban cars from city centers.
Yeah.
Right.
How good is Narwhal's support for data frame QA libraries via Pandera or others? I want to use Narwhals, but could not find a solution for that yet.
So I know that there's a couple of data frame validation libraries that have been written on top of Narwhals. So there's Whimsy and Validupsy. I think Pandera have an issue open in GitHub about using Narwhals, but I don't think they're using it at the moment.
Okay, someone also having some hesitations. I was planning to start learning DuckDB SQL. Are you telling me now that I don't have to and just have to learn Narwhals instead? Smiley, smiley.
There are things you can do in DuckDB that we can't do in Narwhals, so my recommendation is to learn both. However, if you're interested in just trying DuckDB, then maybe Narwhals is a nice shortcut into it. Like just write your Polar's syntax, translate it to SQL, and see how far you get.
Someone is asking about your opinion if Narwhals is going to become part of non-focus or other non-profit organizations.
They've approved us to become part of the affiliated projects, but yeah, I think most of our contributors are just like doing other things as part of their employment, so we've not yet had a chance to apply for any grants to do any funded work, but I'm very excited about what we can do in this space and what we can achieve with funding.
Your energy is getting lower.
Okay, high energy question, let's go.
Narwhals must always keep up with the use libraries that are maybe less stable than it is. How would you handle breaking API changes in the use libraries?
Oh, right. So we do all of this internally. Like we keep track of the backend version for each compliant frame. And then based on that, we choose which API to call. So for pandas version 3, we remove some copy equals false keywords that are no longer necessary, which we have to keep for lower versions to not do unnecessary copies, which would introduce extra overhead.
Someone is wondering if it's possible to access pandas index, for example, date time index in Narwhals.
Ah, right, yeah, very controversial topic, the pandas index. So the stance in Narwhals is that we respect your index. So the index you start with is the index you end up with, but it's not part of, so we do have a function which allows you to get the index back out, but we don't do index alignment in the way that pandas does, because I find it quite unintuitive. But we do preserve the index. So if you really care about the index you start with is the index you end up with.
Is FireDuck a competition?
FireDucks, we do. So FireDucks lets you run like Python -m fireducks.pandas, and then it will swap in FireDucks instead of pandas. So if you've written code using Narwhals, then it still works with FireDucks. So no, not in competition. We are bringing everyone together. We are a project about love and community.
How big is the coverage of the different APIs roughly? Do I have to worry about running into issues because of gaps in the implementation of Narwhals?
I'd say that with every new project that uses Narwhals, we find some gap, and so we add some new features, and so the coverage is becoming more and more extensive, and I'd like to think that it's enough to be dangerous. Like we can execute all of the TPCH queries, for example. That's very relational focused, but still the fact that several libraries are using Narwhals to address all of their data frame needs, I think is a good sign that we've done enough that it's useful.
So did you also cover this question, how Narwhals will handle huge PySpark data frame?
Yes. Is this a record for how many questions we've got through?
Can Narwhals handle cross-library queries?
To be honest, I think cross-library queries are a bit of an anti-pattern, so no. Sorry. As in, like, if you want to pass in a pandas data frame and merge it with a polars data frame, then first it's up to you to make sure they're the same backend. But Narwhals does provide you with ways of going to pandas or to polars, so it could make it a bit easier, but yeah, I really don't recommend mixing backends in the same project.
Okay, I see we covered a lot, so I want to finish with a very important comment and question. About fund, it's more profitable to recycle plastic bottles and aluminum cans than glass bottles and jars. What do you think about that?
My mind is blown.
You should have thought carefully when you started and ended with fund in Germany. There are experts here.
Well, I started and ended with Luften last time, and I didn't get kicked off, so I figured it would be okay.
Well, I see that we can finish and you can answer the rest of questions offline, or people come and approach you before you leave.
Sure thing. Cool. Thanks, everybody. You're the best. Stay safe. Respect the code of conduct. Try Narwhals. Be dataframe-agnostic. Ciao.